Abdul. I'm an application engineer, and we're going to look at some solid edge commands today, and we will wait about another minute as people are continuing to come in. And this week we want to talk about, on our Tech Tuesday, we want to talk about solid edge time-saving commands part 2. A couple weeks ago we talked about some of the time-saving commands found in solid edge, and then we said we had so many of them that we needed actually two different webinars to show them all. So today is part 2. Now, real quickly to explain the Tech Tuesday concept to any of our new viewers. Tech Tuesday is a video newsletter, if you will. We meet every Tuesday afternoon or every Tuesday morning at 11 o'clock. Some of the topics are solid edge, some are NX, some are Z printer, shape grabber, a lot of the engineering hardware that we have for your benefit. But my specialty, my focus, if you will, is the solid edge part of things. So today we are doing the solid edge time-saving commands. This is part 2. It's brought to you by CamLogic. We were founded in 1996 by Jim Carlisle, headquartered in Oxford, Michigan, and we serve Michigan, Ohio, Indiana, and Pennsylvania. Now, we carry the full line of Siemens PLM products, that being Solid Edge, NX, Teamcenter, FEMAP, ChemExpress, Insight. Every piece of software that you need to make your engineering more productive, to make your engineering firm more productive. But then we also carry other products as well, as far as reverse engineering, rapid prototyping, Z printers, shape grabbers, roamer arms, those types of things that allow you to take the physical product and turn it into a digital, or to take the digital product and turn it into a physical part. Any way that you need to go, we carry all of those products for you. So not just carrying, but we also do service and consulting. So it's not just that, this is a sort of a store where you buy your software or your hardware. We also service. We service what we sell. We also service everything we do. All of our people are certified trainers and experts and factory trained, if you will, in their field. So anything that you have from us, you can expect to get full support. One of the nice things that we add, and we're coming up here very shortly on this new tour of Solid Edge and NX and things like that, is local user events, webinars such as this, monthly newsletters, tips and tricks, those types of things. So again, any way that we can be involved with you, our customer, is exactly what we want to be. If we need to be on the shop floor, walking the shop floor with you, that's fine. If we need to be on the other side of the desk, that's fine as well. If you need to come to our training classes, or we need to bring our training classes to you, we can do those as well. So today we're going to talk about time-saving commands. Last I believe it was 2 weeks ago, we looked at synchronous technology, process-specific, property manager, a couple other things like that that we went through. And we said that we had a few more to go through, and that we would save them for another time. And those were assembly, frame, express route, systems library and transfer, draft, quick sheets, principal views, things like that. And again, this idea of a time-saving command is something that you're telling the system, I need to get this one part done very, very quickly. It's almost saying to the computer, I know what needs to be done, you know what needs to be done, let's just go do it. And that's a time-saving command. We don't want to have to go through the process so much. Today, I'd like to talk about the sheet metal and the Auto DXF and some jogs, and I'm going to also look at some synchronous sheet metal as well. So Let's go ahead and get started. I'm going to make a pulley cover for this lawnmower deck that I have out here, and I'm going to make it inside of Synchronous sheet metal. Now I've got a choice. I could make it in ordered, and simply all I have to do is right click and make it in ordered, or I can right click on that banner and transition that over to Synchronous. And so for this demonstration I am going to work in Synchronous. I'm going to take a simple rectangle by center, and I'm going to work with this, and I'm going to pull this center out, and I'm going to make this center a little bit bigger than what we're used to, or just for exaggeration purposes. But notice up at the top of the screen, this particular piece happens to be in metric, which is fine, but up top it's looking for my dimension. So my command line up there is looking for a dimension. I can do that just as well just by typing in. For instance, I want this 190 by 200. I'm going to hit tab, and then I'm going to hit 0 for the angle, and it's going to go lock that area in. Now, inside of Synchronous technology, any enclosed area, such as this rectangle that we have here, is called a region. Now, that allows me to go drag out go start my part. The time-saving command about this in Synchronous sheet metal is as soon as I touch this region, my material table comes up. So very strong, very, very powerful. Already I don't have to go hunting for that. I don't have to make it, then change it, that type of thing. My material table already pops up the minute that I pick on that region, because it understands that it's sheet metal. Now, I want to come down with some sides on this piece, and I'm going to go hit the space bar, and the space bar is pretty much like the control. It allows me to pick multiple sides, so I'm going to come down 3 sides at once. Now notice we're not even using the word flange, because Solid Edge simply knows if I pick that side and I start to bring it down, there's only one thing that thing can do, and that is come down as a flange. So again, the time-saving commands, I'm not going through the ribbon bar. I'm not trying to learn the system. I'm saying, yeah, these have to have sides, if you will. Okay, so they're going to come down. You can call them sides. Solid Edge is going to end up calling them flanges. We understand what's going on. And I'm just going to take it down to this deck and leave it right like that. So now I've got a part setting out here, and it's got 3 walls and 1 open side. Now, there's a couple things that I need to do with this, and that is to allow some clearance. So, when you first make something, it's going to interfere with a bunch of stuff. That's fine. I can go out and work on that face, and I'm going to work on this face and just pop a line, and you notice it's going to set right parallel to the plane that I chose. So it's just as if in the ordered, it's just as if I twisted it right toward me, and I was perpendicular to it. But here, I get to go drive it in Synchronous. I get to drive it right live on the screen. So as I do this, I'm simply going to let this line be the beginning of my jog line, and I'm going to bring this out approximately, we are in metric, approximately 35 millimeters, and I'm going to bring that out. So that helps a little bit of what I wanted to do, but I still have things that are in the way. So I'm developing my product in the context of the assembly. That's another space or another time-saving workflow that we have, is I'm working in the context of the assembly so I can actually see how my part's going to fit. I'm not making it off over in a vacuum and hoping that it fits. I'm working right in the context of my assembly so I can see what needs to change and what needs to stay put. In this case, this face, even though I brought it out, still interferes with everything that I've got. Now, down at the bottom of my screen are my live rules. Synchronous technology, whenever I pick a face, it analyzes that face and it says these are the live rules that apply. Things such as tangent or concentric, tangent, coplanar, things that type of relationships that I have. So I'm going to turn off my coplanar and my symmetrical. In other words, I don't want anything behind here, and I don't want anything on the other side, the left-hand side of this, if you will. I only want this face. So I'm going to take that face and just take my steering wheel. We're going to learn about that in a couple of weeks. And I'm going to take my steering wheel and just flip this right out just until it clears. Now, again, you see me kind of dragging this around. I think I'm going to make that about 32 millimeters. I'll hit tab just so I can see the result. And then you can see that all I was really concerned about was that it cleared the idler spring that I had over here. So that was all I was really concerned about. Okay, so very, very strong, very, very powerful set of tools helps me design this very, very quickly. Now you notice when I brought this over that it's going to interfere with this little tab that we have over here. So I'm just going to take this, and instead of making a flange, I'm going to just pull this whole face back. And Solid Edge with Synchronous technology understands that the whole part needs to be a little smaller as I do that. Now, I'm going to lay the foundation for this in the future, and I'm going to take this face and do the same thing as well. And I'm just going to bring this face over just a little more. Okay, so I might bring that over about 25 degrees there as I have that, and we'll hit tab. I believe I said 35 millimeters on the last one, but it was actually I meant to say 35 degrees. So I'm going to move that over, giving me a little more clearance for what I'm going to do in the future. I'm going to spin around on the back side of this. I want to close up this gap, and all I have to do is just touch that and pull. And if I pull one way, it's going to be longer, but if I pull 90 degrees to it, it's going to go out, and it's going to give me a flange. Now, it's going to give me a flange at kind of an odd angle. It's actually 90 degrees to that face, and if you're looking at this, it doesn't quite look exactly the way we want to, but that's okay, because when I click on this face again, I have the ability to relate. And relate is a command, a time-saving command that allows me to go out and sort of introduce or impose my design intent, my history. That was one of the things that people complained about when Ordered came out, or when Synchronous came out, is that you would lose all design history. Now, that's not true. With Synchronous, I'm in control of my design. I'm in control of my design intent. So for this case, I'm going to go make this face concentric to this face, or concentric, I'm sorry, coincident with that face. Solid Edge is going to go take that flange and turn it so that it's in line with this face. So I want to bring this gap, and I want to close this gap over, but I don't want this edge to touch this edge over here. Okay, I'm perfectly willing to have a little bit of a gap. So how do we do that? I'm going to hold down the Shift button and grab the primary axis of my steering wheel. And as I do, Solid Edge instantly is looking for an input, so I'm going to have that handle move 1 millimeter out from that face. So as I grab this and start to move, my handle is now 1 millimeter off of the face, almost like moving 2D. I want to move something from here to here. Where do you want it to start? You can move it right in the center, or off to the side, or wherever you like. That's where I want it to start from. Where do I want to move it to? So my handle is 1 millimeter off of my face, and I want that handle to move to the endpoint there. automatically leaving a 1 millimeter gap between that face. Very strong, very, very powerful. I don't have to go out and second guess what I've been trying to do. Now, as I have this, just looking from the back side here, I may want to go out and make some flanges. And again, I haven't touched anything up on the top step ribbon, the top ribbon bar up here. Haven't touched anything up there. I'm simply running through my commands or running through my design iteration the way I want to. So I'd like to take this face, I'm going to hit the space bar, and I want this face, so I'm going to simultaneously, synchronously, I'm going to go out and pull this tab out just to the endpoint of out there. So I'm going to instantly kind of take care of that side, but I'm also going to take care of this side as well. Now, it seems like we're just sort of grabbing and dragging and moving and working with clay, and that there's no real design intent, or there's no protection to what I'm doing. And that's not the case. At this point, I can start dimensioning, and I'm going to go ahead and dimension this, and I'm going to lock this dimension, and right now it's 34.88. It's just as easy for me to round it up there and make it 35. And I'm going to leave that locked, and that's going to be a red dimension, which tells me that, if you will, that's a driving dimension. That is, if you want to call it your primary dimension, if you want to call it your design dimension, call it anything you like. But what I'm doing is I'm saying this stays. At the expense of everything else, this dimension is going to stay the way I want it. What does that allow me to do? Well, again, that allows me to go back and synchronously move some things around that I've got over here. And I'm going to turn my coplanar on because I want to catch this back face. I could have picked it just as well, but by turning my coplanar on my live rules, it allows the computer to pick that face for me, so I don't have to go out and look at this. So all I have to do is just move this over, and again I'll move it over, let's say somewhere around 22 degrees, and I'll hit tab just so I can kind of get the idea of what I'm talking about right over here. So I've got my tabs, and now I need to put my holes in here as I've moved this around. I want to introduce a tool in Synchronous called Project to Sketch, and I'm going to be working out on this plane right here, and I'll zoom in just so you can see this. I'm going to project to sketch, project with offset. Yes, that's very much like include with offset, and I'm out in traditional, and I'm going to take that circle that I have, and I'm just going to make it bigger than what was right there. So again, I'll just take that, make it bigger, and bring it out like that. Now, at this point, I'm going to hide the rest of that assembly so we can see more of what we were working on. And I'm going to take this region, hit my space bar, come around, hit that region. So now I'm taking both regions at the same time, and I'm just going to bust a hole right through there, giving me exactly what I want. And now they're going to fit. Those bolts are automatically going to fit on that plate. I don't have to worry about, does that plate fit into this environment or not. So very, very strong, very, very powerful. But speaking of fitting, I want you to see this bolt, this shaft right here. Spin around down here. Once you see the shaft right here, and the top of that nut is actually interfering with that plate. So I'd like to put a little bit of a relief up there, and for that I'll go back over and use my project to sketch. So this is the plane I ultimately want to work on, but I'm going to sneak down in here, and I'm going to grab the circle of that. I'm going to grab the circle of that belt, and I'm going to grab the edge of that belt, and I'll spin right around, and I'll grab the edge of that belt. That instantly, to save time, instantly makes a region that my dimple command can access to bring this up. So once again, using the tools, the products that I have, Solid Edge is going to allow me to design my parts very, very quickly in place. I know that this piece works. I know that it fits. I know that the holes are aligned. I know everything that I need to know about this part, that it's going to work for me, simply because I used Solid Edge, I used Synchronous technology, and I designed in the context of the assembly. So very, very key concepts here. At this point, I'll go out and make a flat pattern. And Solid Edge will put this flat pattern out, give me exactly what I want, show me the size that it'll take, 287, 601. It gives me the exact size that I'm going to take, or that I'm going to need for my flat pattern. By going back to my Synchronous technology, back at how does it look inside of the Synchronous, I'll save this part, and then I'll go to my application button and show you what was introduced in ST3, and that is on the flat pattern treatments. I am going to use the existing flat pattern. Okay, so when I save as flat, I don't have to go recreate this. So I'm going to use an existing flat pattern for my DXF. So as I do that, save as flat, all I have to do is hit save, and I'm going to get exactly what I want. Now, at this point, let me go back up to the assembly, just so you can see that. We can kind of put this DXF thing to rest. I'm going to go ahead and open the DXF, and we'll bring it out here on a ANSI draft. Okay, so I'm going to go ahead and open that DXF. So my DXF is automatically going to set out here my up features, my down center lines, my interior loops, my exterior loops, guaranteed one-to-one setting out there waiting for me to work with this. So as I go back to my assembly, and then back to this part, just so we can see the part just itself. New, create drawing. Time-saving command number 2 or 3 here, if you're counting. We want to go out and we want to make a draft of this, but I am not going to run the drawing view creation wizard. Well, if I choose not to, what's going to happen is the drawing is automatically going to put the top, front, and right side in there for me. So I don't have to go through that. Again, we're saving 10 minutes here, 15 minutes here, that type of thing, and going through this on time-saving commands. So I'm going to scale this down just a little bit. I'd like to get a little more room into what we're doing. So I've got this, and always do this. I like to do this just as often as I can. I'm going to go out and do a principal view, and I'm going to bring over an ISO because, again, a picture is worth 1,000 words. And I may come over here and insert a second sheet. And I'll go, at this time, I will go through my view wizard, and I'll pick my flat pattern. I'll just pick the top. If you learn that when you're picking the flat pattern, that the top view is going to contain the best view, you'll be fine. So we'll go over and just hit finish, and I'm just going to drop my my flat pattern in here. Again, now this is not the DXF. This is not what the laser is going to run off of. This is what you're going to inspect off of or bend to. And speaking of bend to, we'll just simply click a bend table and have our bends automatically numbered and then charted out there for us. So again, very, very easy commands to work with, synchronous technology, very, very quick, very, very intuitive. If I'm working in the context of this assembly, very, very easy to design a part that is going to give me exactly what I'm thinking of. Well, that concludes it for the demonstration portion for today. Just want to tell you about our training. We do offer training. We offer it on site, on classroom, and also customized. Anything that you need, we can take something sort of off the shelf, or we can take a list of your needs, add a few more lists, or add a few more things that we would suggest, and then teach your folks. So please keep us in mind for all your training needs, all your consulting, and even your hardware needs as far as scanning and printing. Coming up May 3rd is the Solid Edge Synchronous Steering Wheel. May 10th and 17th, special interest to our NX people. We'll be looking into PMI and also blending and then tips and tricks. Back on May 24th, I'll be back with working in a multiple CAD environment. So not everyone is using Solid Edge yet. That's something we're working on, but until the whole world switches over, we'll show you how to work with other people's files. Also, May 31st, Introduction to Solid Edge Insight. This session will be replayed. It can be found at camlogic.com under Gallery and Videos. So this Tech Tuesday session will be out with every other Tech Tuesday. Also, some shorter videos that we have can be found on YouTube. We have a CamLogic channel. You can always reach us by coming to camlogic.com, looking at our website, or even contacting us, if you will. Again, my name is Dale Duell. My office number is 248-969-9201, extension 6209, extension 6209, or you can always reach me on my cell phone, 740-341-4902, or daledee@camlogic.com. I appreciate your time. I appreciate your feedback. I would love to hear from you. Let us know what we need to cover. We'll be more than happy to make a Tech Tuesday to answer that need. Thank you so much for attending. This concludes our Tech Tuesday for today.